So in this video, we're going to go over the problems that are in the Unit A test review. So in this first question, it asks you to match the equation of the function to the graph that's given below. So I think if I was doing this problem, my best bet would be to go ahead and graph all of these functions in Desmos, and then you can use the key features to identify which equation matches the graph. So when you graph all of these, you want to be looking for things that you see on the graph pictured here. So for example, you can see the x-intercept at 15, 0, the y-intercept at 0, -3. Notice that this graph has a minimum, right? So that minimum will occur at -1 and -4. So you want to look for the equation that matches the graph with all these key features. And when you do that, you'll find that equation A is the one that matches this graph. So now in this problem, it gives you this equation, f of x equals the square root of x plus 5, and it wants you to find the x-intercept. The quickest way to do this is to graph this function in Desmos, and then remember, if you click on that point, that's the x-intercept. Remember, that's where the graph will cross the x-axis. It's just going to give you the coordinates. If you want to do this algebraically, remember at the x-intercept, the y-coordinate is going to be 0, right? Because we have x0 for our x-intercept. So you can basically set this equation equal to 0, and you can solve for the value of x if you want to do this algebraically. Remember, now I'm going to square both sides, and then I'm going to get 0 equals x plus 5. And then if I just subtract 5 from both sides to solve for x, I'm going to get -5 equals x. So that's why the x-intercept is going to be at -5, 0. So now in this problem, it asks us for the domain of f of x equals the square root of x plus 4 minus 3. Once again, the quickest way to do this is to go ahead and graph this in Desmos. And when you get this graph, remember that the domain is all the x values, right? So that's going to go from left to right. So the leftmost point of this graph, you can see here, it occurs at x equals -4. That point is included, so remember I'm going to put a square bracket at -4. And then at the rightmost point, well, this graph just keeps going to the right forever, right? You can zoom in Desmos and you can see that it's going to go on forever. Remember, that means it's headed to positive infinity. So I'm going to write infinity. Since infinity is not a specific number, I'm going to use an open parentheses with that. Okay, so that's the domain. Now let's try the range. So this is the same function, f of x equals the square root of x plus 4 minus 3. Remember that the range is all the possible y values. Okay, so the range is going to go low to high. So if I look at this graph, I'm going to try to figure out where the bottom of my graph is, right? So the lowest point on my graph, like the bottom of my graph, is right here. That is at y equals -3, which is an included point. So I'm going to put square bracket -3. And then from there, notice my graph is going up. Okay, so if it's going up, it's headed to positive infinity. So I write infinity, and then I use my open parentheses. So that is the range of this function. Okay, so now it gives us this equation, g of x equals the square root of x minus 6, and it wants us to say how it's been transformed from the parent function, f of x equals the square root of x. So one thing that's really useful to use here is this chart that's in your study guides. Notice that it's an x minus 6 situation, right? So that's going to be an x minus h, right? Because the change is on the inside, so it's horizontal. Remember, that's the one that kind of does the opposite. So that x minus h is going to be a shift right 6 units. Remember, you can always graph a transformed function and the parent function in Desmos to compare also. Here in black, you have the parent function, f of x equals the square root of x. Notice that the green, the transformed function, is shifted to the right 6 units. So now it gives us some descriptions and wants us to write the equation. So we have a vertical stretch by 5 and shifted down 3 to form g of x. So vertical stretch, okay, if we go to our chart right here, that's when a is greater than 1. Okay, so what I'm going to do is I'm going to go to my transformed function, g of x, and the first thing I'm going to do is put that 5 in front of my square root. Okay, and then it says shifted down 3. Well, down 3 is going to be a value of k, right? So because it says minus k means down 3. So I'm going to leave this x on the inside alone, okay, and then I'm going to put that minus 3 on the outside. So that is now the transformed function. Remember that it changes signs depending on the shift, right? If this had been a shift up, I would have had a plus sign here, but the minus is because it tells me that it shifted down. Okay, now let's try solving some equations. So here we have a square root equation. Remember, whenever we're solving a square root equation, the first step is to make sure that the square root has been isolated. The square root's already by itself on one side of the equation, so I'm going to go ahead and undo that square root by squaring both sides. When I square both sides, I get x minus 2 equals, and then I have 7 squared, so that's 49. Now what I need to do is solve for x. So remember, I can solve for x using those opposite operations. Here I have a minus 2. The opposite of minus 2 is to add 2, so I'm going to add 2 to both sides, and that's going to give me x equals 49 plus 2, which is 51. Remember, whenever we're solving square root equations, we always want to plug our answer back in to check and make sure we don't have any extraneous solutions. So if I plug in 51, I get the square root of 51 minus 2, right? Because that 51 will replace x. And we're checking if that's equal to 7. So we have the square root of 49, and that does in fact equal 7, so our answer is good. X equals 51. So now let's try solving here for x. Well, notice in this equation, the square root is not isolated, right? It's not by itself on one side of the equation. So the first step is to actually go ahead and isolate the square root. Well, why is the square root not by itself? It's not by itself because of this 6 right here. That 6 is a positive 6, right? So it's like there's a plus sign here, but we just haven't written it because we know it's a positive number. So the opposite of 6 is going to be to subtract 6 from both sides. So I subtract 6 from both sides, and that gives me the square root of 2x minus 3 equals 11 minus 6, which is 5. Now that the square root has been isolated, I can go ahead and square both sides. So when the square root's by itself, you can undo it by squaring both sides. And so we get 2x minus 3 equals 5 squared, which is 25. Now we just need to work on getting x by itself. Okay, so to get x by itself, I'm going to start off by adding 3 to both sides. So when I do that, I get 2x equals 28. Okay, and then now to solve for x, I need to get rid of that 2. Remember that 2 is multiplying x, so I'm going to undo that by dividing both sides by 2. So I get x equals 28 divided by 2, which is 14. I want to go ahead and check my solution, so I have 6 plus the square root of 2 times 14 minus 3 equals 11. So that gives me 6 plus the square root, 2 times 14 is 28, so 28 minus 3, does that equal 11? Well, that's telling me that 6 plus the square root of 25 equals 11, which is 6 plus 5 equals 11, which is in fact true. So x equals 14. Okay, now let's try this equation. So here, the square root is isolated, right? The square root of x plus 10 is by itself on one side of the equation. So I'm going to go ahead and square both sides. When I square both sides, the very, very important thing to remember here is that x plus 8, the whole thing is being squared, okay? So when I square that x plus 8, remember from last semester, that means basically that is x plus 8 times x plus 8. Okay, now what I actually need to do is I need to FOIL that. And so when I FOIL it, I get x times x, which is x squared. The outside x times 8, which is 8x. Inside 8 times x, which is 8x. And then last times the last 8 times 8, which is 64. When I add up all these terms, I get x squared plus 8x plus 8x plus 64. So I have x squared plus 16x plus 64 when I combine those like terms that are in the middle. So that's going to give me x plus 10, right? Because on the left side, all I do is undo the square root, and then I have x squared plus 16x plus 64, right? That came from over here. Okay, now I need to solve this equation. Well, notice this is a quadratic equation, right? It's a quadratic because my highest degree term is a square term. So remember, in quadratics, we always want to get them into standard form, right? Ax squared plus bx plus c equals 0. So in order to do that, I'm going to move all my terms over to the right side of my equation. So I'm going to subtract x, and I'm subtracting 10 from both sides. Remember, when I'm doing this, I can only combine like terms, okay? So x's combined with x's, and then constants combined with constants. So x minus x, and then 10 minus 10, that just leaves me with 0, and then I have x squared. 16x minus x, that's a 1x, so I have plus 15x, and then plus 64 minus 10, which is 54. Now I need to solve for x. Well, my favorite way to solve quadratics is by factoring. So I'm going to go ahead and factor. So I need two numbers that multiply to 54 and add up to 15. So that is going to be x plus 6 times x plus 9. Okay, and then I can just solve this by setting each of my factors equal to 0. So I'm going to get x equals negative 6 and then x equals negative 9. Now remember, I always need to plug in my solutions and check. So I'm going to start off by checking x equals negative 6. So I have the square root of negative 6 plus 10, and I'm checking if that equals negative 6 plus 8. So I have the square root of 4 is equal to negative 6 plus 8, which is 2. So that's telling me that 2 equals 2, which is good. So negative 6 is a good solution. Now I'm going to check whether the square root of negative 9 plus 10 is equal to negative 9 plus 8. So the square root of negative 9 plus 10 is the square root of 1, and I'm checking if that is equal to negative 9 plus 8, which is negative 1. That's telling me the square root of -1 is equal to -1, and that is not true. Okay, so that -9 is an extraneous solution, and we don't include that in our final answer. So the only solution to this equation is x equals -6. So now let's look at this problem. It tells us how has g of x equals 5 square root of x minus 4 plus 7 been transformed from the parent function f of x equals the square root of x. So this is where I like to go ahead and look at each of the numbers separately and think about the transformation. So I have a 5, I have a -4, and I have a plus 7 that I need to think about. Well, that 5 is in front, right? That 5 is a value of a. The absolute value of 5 is 5, and that is greater than 1. So that is going to be a vertical stretch, okay? So we're going to say vertical stretch by 5, okay? Now for that -4. Okay, so we have like a whole x minus 4 situation here, right? So that's like an x minus h situation, which tells us that it's a shift right. Okay, so this is going to be a shift right 4. And finally, we have this plus 7 that's hanging out on the outside, okay? So anything hanging out on the outside is going to be like that plus k. And remember, that tells us that it goes up. So that plus 7 is going to be a shift up 7. Okay, so now let's think about this. Now we're into finding some inverses. So what function represents the inverse of f of x equals the square root of x plus 7? Remember, there are 3 steps to finding the inverse, okay? Step 1, we replace f of x with y. Step 2, we switch out our x and y values. And then 3, we just go ahead and solve for y. Okay, so now let's start off with this. F of x we replace with y, so we have y equals the square root of x plus 7. We're going to switch x and y, so we have x equals the square root of y plus 7. Now we need to work on getting y by itself. When we want to get y by itself, we have to start off by undoing that square root because everything in this problem is like trapped under that square root. So we have x squared equals y plus 7. Now to get y by itself, we're going to go ahead and subtract 7 from both sides. So when we subtract 7 from both sides, we get x squared minus 7 equals y. Well, this is a quadratic that's representing the inverse of this square root function. So remember, we need to include our domain restriction in our final answer. So we have f inverse of x equals x squared minus 7. And this is going to be true. What we're going to do is take that part that's being squared, set it greater than or equal to 0. So we have x squared minus 7 for all x greater than or equal to 0. And that is the inverse. So on this problem, we're also once again finding the inverse. So same 3 steps as before, right? So these 3 steps where we set f of x equal to y, switch x and y, and then solve for y. I'm just going to copy over here. And then let's go ahead and do that. So we have y equals the square root of x minus 10. Let's switch x and y. X equals the square root of y minus 10. And now let's solve for y. So we add 10 to both sides. And when we do that, we get x plus 10 equals the square root of y. Okay, so that y needs to be isolated. So I'm going to get rid of that square root. So I can do that by squaring both sides. When I square both sides, I get x plus 10 squared equals y. So that is now going to be my inverse function, x plus 10 squared. And since it's a quadratic that's representing the inverse of a square root function, I need to think about my domain restriction. So I'm going to take that part that's being squared, that x plus 10, and then I'm going to set it greater than or equal to 0 and then solve for x. So I can do that by subtracting 10 from both sides. So I have x is greater than or equal to negative 10. So my inverse is going to be x plus 10 squared for all x that is greater than or equal to negative 10. Okay, and there's my inverse. So that's all the problems that are in the test review. So if you have any questions, please be sure and reach out.